The University of KwaZulu-Natal's College of Agriculture, Engineering and Science is committed to making a difference in our world, from the classroom and laboratory to the field. It provides one of the finest study and research environments on the African continent and is recognized internationally as a center of excellence. Agriculture, Engineering and Science is one of 4 colleges that make up the University of KwaZulu-Natal and is home to over 8,700 students and approximately 700 staff. 3 of the university's 5 campuses form the core of agriculture, engineering and science activities in the region. The college comprises 5 schools: agricultural, earth and environmental sciences, engineering, chemistry and physics, life sciences and mathematics, statistics and computer science. Engineering is offered on the Howard College campus, agriculture on the Pietermaritzburg, and all the other sciences on both the Pietermaritzburg and Westville campuses. Exceptions are agricultural engineering, which is offered in Pietermaritzburg, and geology, which is offered at Westville only. To compete with the best and to meet the challenges of the 21st century, South Africa needs highly skilled professionals in the areas of agriculture, engineering and science. We offer a wide array of interesting and innovative degree programs that open doors to a variety of different careers. Some degrees are unique to UKZN and are not offered at other tertiary institutions. For example, we are the only university in South Africa to offer a fully accredited agricultural engineering degree and one of only 2 universities in the country to offer a BSc in land surveying. Our postgraduate food security training program is the only one in the world, and we have the widest range of agricultural disciplines at any single South African or African campus. The choices of degree and the options on offer may seem confusing at first. Engineering degrees are more specific, and the options are usually career-focused. Emphasis is placed on training in the specific principles which engineers deal with in their professions. Engineering offers 7 different professional specializations. There are also degrees in land surveying or geomatics and property development. In science, there are structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science, and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology, and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of health and the treatment of disease. Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations under full field conditions. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Ukulinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Westville campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Centre showcases the college's scientific achievements and promotes the public understanding of science, engineering and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. The college has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centres within the college. The African Centre for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Centre for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Centre for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centres at the university, the Centre for Plant Growth and Development focuses on high-quality research in the plant-based disciplines of plant physiology, plant molecular biology, and ethnobotany. The Centre for Quantum Technology deals with physical phenomena at the microscopic level. Quantum physics led to the development of the transistor and the laser and is currently being used to develop quantum computers and quantum cryptography. The college is committed to access and readdressing the disadvantages and inequities of the past. The highly successful Unite Engineering program and the Science Access Foundation and augmented programs offer alternative access to university equipping students from disadvantaged backgrounds with the skills and knowledge to pursue their degrees of choice. Both these programs contribute significantly to advancing Black African scientists and engineers in South Africa. Staff and students contribute to a number of outreach and community initiatives that focus on social responsibility, sustainable development and upliftment of the wider community. The college also engages in activities involving the pursuit and understanding of science, engineering and technology through exhibitions, festivals and roadshows that target high school learners and the general public. The college has minimum entry requirements for its programs. These differ from degree to degree, but all require a national senior certificate and minimum performance levels in mathematics and either physical or life or agricultural sciences. For those who do not meet the minimum requirements, access programs are available. Additional information and brochures can be obtained from the contact information accompanying this video. The College of Agriculture, Engineering and Science is proud of its contribution to the university, the region and the country.
UKZN is one of the best. I definitely understand it's one of the best in South Africa. So for me, there was no other institute that I would have preferred other than UKZN.
We have the best facilities here in terms of laboratories, in terms of equipment, in terms of human resources, in terms of literature.
UKZN is one of the best universities in the country that teach agriculture or natural sciences.
What I think is good about this college is the level of international collaboration that we have. We have friendships with universities all over the world, which means that we're keeping up to a great international standard.
UKZN has got much more facilities and it's recommended worldwide to do your science studies here. Life begins here. Yes.
We continually strive to be academically excellent, innovative in research, and critically engaged with society. We invite you to join us or work with us to be part of this exciting team.
All right. Greetings, colleagues.
Yes.
I mean, it's up to you. I'm not sure if you're ready to start or you want me to play for another video for some few minutes to wait for others. I don't know.
I'm ready to start. I mean, if people are here, we can start, unless if you want us to wait a little bit, but I'm ready.
Okay, maybe let's start at about 5 past. Let's see in time if there's some people who are still joining.
Okay, perfect.
Okay. I will play for another video in the meantime then.
Okay, no problem.
Kindly mute yourself, guys, please.
Step 2. Have a look through the various courses offered and choose a program that interests you and for which you meet the minimum requirements. As one of the top 5 universities in the country, UKZN promotes academic excellence. So meeting the minimum requirements does not guarantee you a place to study. Step 3. Find the program code linked to your chosen qualification. This is the code you need to enter in your application form. Okay, let me show you something. You see, a code has 3 parts. Example, for BCom in accounting, the code is KN-P-BCN or KN-W-BCN. Crazy code, right? Well, basically, the KN stands for UKZN, the middle part stands for the campus of your choice, P for Pietermaritzburg, W for Westville. Then BCN stands for the actual course. Make sure to get these codes right. Step 4. Use this program code when completing your CAO form, which is available from the CAO website. Your application will be sent to UKZN. You can always check the status of your application using your CAO number, ID number, or passport number on this website, www.caocheck.ukzn.ac.za. For more information, visit www.cao.ac.za. It's that easy. Pay close attention to closing dates for qualifications. For example, MBCHB closes on the 30th of June, whilst other undergraduate programs close on the 30th of September. What are you waiting for? Apply now and shape your future today.
Thanks, guys. Thanks, colleagues. Over to you now.
Good afternoon. I hope people can hear me. Am I audible?
Yes.
Clear.
Okay, perfect. So yeah, today we are covering a very special topic in mathematics paper 2, which deals with the analytical geometry of the cycle. And below that, we want to find the equation of a tangent to a cycle, right? So now our objectives is to, okay, perfect. So one, we want to find the equation of a cycle centered at the origin. That's the first objective. Then the second objective is to find the equation of a cycle centered at a particular point, A, B. And then from there, we want to find the equation of a tangent line. So given this scenario, so we want to be able to find that equation of a straight line which touches the cycle once. Okay, so I will try to be as clear as possible. Okay. Someone is saying that it's not clear, it's not audible. Let me try to increase the volume from my side. Let's see here. Okay, I will just try to be very loud. All right, so first let's motivate the equation. How would you find an equation of a cycle centered at the origin? So we have a Cartesian coordinate where you have X, you have Y, and this is the origin, we call it O. Then we have a cycle which is centered at O, and we have a point, we call it P, with that coordinate. Is someone writing on the screen? Or is it me? I'm not sure. So now this is O. We are told the distance between O and R and O and P is R. So we want to find the relationship between O and R. So we use the distance formula. So the distance formula tells us that we can find the distance OP to be the square root of the point at O, 0, 0. So we will have X minus 0 all squared plus X minus, Y all squared. So if we continue, this will be X squared, Y squared. So if we square both sides, we would get OP squared is equals to X squared plus Y. But we have defined OP to be equals to R. So that means that X squared plus Y squared is equals to R squared. So this is the equation of a cycle centered at the origin. Yeah. So, yeah. So if there's any urgent question, my colleagues, you just jump in and you just use the audio or the voice just to correct.
Sorry,
me.
sir.
Yes.
Sir, I think someone drew on your screen. We can't see. There's like a yellow drawing.
Can someone remove? How do you do this?
Any advice, colleagues, how we can?
Okay, I will just, what I will do, I will just stop sharing and then share again.
All right.
Yeah, perfect. So what I was explaining was trying to motivate the derivation of the equation of a cycle and to say that you use the distance formula to derive that. And this is the final solution. So this is applicable whenever you have a cycle that is centered at the origin. But that's not always the case. You will find that there is a cycle which is not centered at the origin. So how do we deal with that situation? So we start from the Cartesian. So this is X, that is Y. So forgive me, I am not drawing this cycle on scale. So no, that's not right. So I may just use that. So this is A, B, and we have a point X, Y, and we can just have that. Now, so we name that distance R, we call this point O, that is P. So we follow the same logic. We want to find the distance between O and P. So using the distance formula, we have O. So we say that we have X minus A squared plus Y minus B squared. I'm not sure why is it not clear. Okay, perfect. So when we square both sides, we know that OP is equal to R. So this is R squared right? So this is the equation of a cycle when it's not centered at the origin. So I think we have the basics to deal with the first part of the session, which is to find either sometimes they will say find the center or find the radius given the coordinate. So the first problem that I want us to look at, this is a worksheet. So can you attempt?
Sorry, sir.
Yes.
Sir, please explain again, like when do you use those formulas? When do you use the one with the R squared and the other one? Like, I don't understand.
Okay. So this is a general equation of a cycle. So what is important here to specify a cycle? What do you need? One, it's the center. So in this case, as you can see, this is the center of a cycle, and it has a radius R, and there's a particular point P, which has the coordinates X, Y. So now the center is specified by A, B, and we can also have important information, the radius R. So it means that any point in that cycle, they have equal distance, which is, we call it R. So to specify a cycle, you need the center and you also need the R distance. So the question is, when do you use this formula or the one that I've just shown, X squared, Y squared is equal to R squared, right? So let's take a case where A is equal to 0, B is equal to 0. So in other words, our center is 0, 0. So when we substitute in that equation, what do we get? We write it first. Normally, R squared is on the right-hand side. So in this case, we know that the center is 0, 0. So we have X minus 0 squared plus Y minus 0 squared is equal to R squared. So that gives us this. Yes. So what we can notice here is that this is the general form. So this is a general form. So whenever we have a radius, whenever we have a cycle, whether it's at the origin or it's at the particular point away from the origin, we can always use that formula, that equation. So all we need is the center and the radius. So we can take an example Did you get answered?
Yeah, yeah, sir. Thank you.
Okay, thank you. So let's have an example. Here is an example. So now I'm just going to allow you to attempt that problem. Then I can give a solution. So we start with question number 1. So I will just assist you with a diagram. So we have a center, we call it A. It has that coordinate. And we have a point, we call it B, which is probably somewhere here. And it has that coordinate, right? So the question is, here is the question. Question number 1, this is the diagram. So find
Can you make a screen a little bit clear? The screen is not clear.
Yes, that's what I'm trying to do.
Okay, now it's a little bit better.
Yes. So
Yeah.
we are doing question number 1. The question is, determine the equation of a cyclic with a center A with coordinates 3, -4, and passing through the point B, which has coordinates 1 and -1. So yeah, I'm giving you 3 minutes. All right, so let's work on the solution. All right, so we are given, you start with the diagram. It's always a good idea to have a visual picture. This is radius R. So using our equation, first we want to find the center. That's number 1. So in this case, it is given. We are told that the center, in this case, A is equals to 3, and then B is equals to -1. So all we need to do is to take the general equation and substitute. So we have x -3 squared plus y minus r squared. Now you can see that there's a negative sign. the rule tells us that we have to have positive. So this is plus 5 squared, right? That is number 1. But we are not complete because now we need to find the radius. How do we find the radius? We take the second point. So when we substitute, if we can remember this point, we called it x and y. So in this case, x is equals to 1 and y is equals to -1, right? So when we substitute from, we call this equation 1, we have x1 minus 3 plus -1 plus 5 is equals to r squared. Okay, so we just need to use a simple calculator on your head. So this is 16, and we can see that r squared is equals to 20 now, which means r is plus or minus 20. But we know that physically the radius cannot be negative because it's a distance. So which means the radius is square root of 20. So you can leave it here as a set form. So to write it clean, yeah. So eventually we will have x squared minus 3 squared plus y plus 5 squared is equals to 20. That is the equation of a cycle. So we are done. Yeah. So are there any questions that I need to address? Maybe because I'm not able to see the chat, if I can be assisted.
Can you just write out the equation in full? So x
Okay,
minus 3
express it or expand. Okay, that's a very good point. So we can carry on from here and so when we expand, we will have x okay. So this is something that we've seen before. There is no need to
So why are we expanding?
it's just for completeness. It's just to, yeah, it's just to make it complete and clean. Just, yeah, it's equivalent. Maybe my colleagues can add a point because it's a good question. I mean, why would you want to do that?
Can I ask something here?
Yes, you can ask.
Like you can able to find the coordinate of a center, even if you expand this, like you complete a square and find the coordinate of a center, right?
Yeah, we will have an example which we will cover that. Yeah, but what we were given, if we can remember, we were given two coordinates. You see?
Yes, I see.
So in this case, if you are given coordinates, they ask you to find the equation of a cycle. So you can be at that point, But because you are a matric person, you are very knowledgeable, you can carry on and expand. And what you can find out eventually, that you can have x squared 10y, and then you transpose these two, 20 minus 25 minus 9. Yeah, using your calculator, if in your head, you can find that this is 5 minus 14. This would be negative 14.
Yes.
Yes, so you will have that. Yes, but it's always clean if you just write it like this. It looks like a usual equation with 0 on the right hand side. Yeah. Okay. Yeah. So to answer your question, let's have another problem.
Yes.
Let's have another problem that can force us to have that situation. So that is problem number 6. But just to exercise and warm up without compromising the interest of other people.
Yes.
Can you do question number 2? Yeah, question number 2. Yeah. So can people mute themselves if they're not talking so that we can have a clear sound? Thank you. So 3 minutes.
Please mute yourself.
Okay, so let's deal with question number 2. Okay, so here we are given the equation of a cycle. Someone has already done work. So we are asked to find the radius of a cycle. This is 2.1. So in this case, we know that this is the general formula. And that means that the center is 0. So to find R squared is equals to 100. Then if you take the square root of both sides, you would get 10 plus or minus. But since R has always to be, must always be greater than 0, that means that R is 10. So we have found the radius. Then number 2.2.
Sorry, sir.
We are given.
Can you also just write it as with the center radius form, so we can see how it applies to the general form? So that x squared is x minus 0 all squared plus y minus 0 all squared. Okay. Then we've got a link. Yeah, thank you.
Okay, thank you. So now if we express now, that means that our center A, B is equals to, so if you say X equal to 0, then that means that X is 0, and then you will know that Y is 0. You do the same thing for Y, that means Y is 0. So the center is 0 in this case. Then you want to find the radius, you equate r squared to 100, then you take the square root of both sides, then the square root of 100 is 10. Now you have plus or minus, you take only the positive number because the r is a physical distance, so a distance can never be negative. So that's why we take positive 10. All right. So again, in this case, we have y squared is equals to b. So if we express this in a similar fashion, we will have x minus 0 squared plus a minus y 0 squared is equals to b. Now, if we divide by a on both sides, we have a minus 0 squared plus 0 squared is equals to b over a. Now, we can see that r squared in this case should be b over a. If we follow from a general formula that says a squared plus a squared minus, x minus a squared, x minus a all squared is equals to that. So we can see similarities that again, a is 0, b is 0. So r is equals to that. Now, if we will have plus or minus square root of b over a. So now a is always positive. R is always positive. That means that our radius over b.
Just to avoid confusion, where you got x minus a squared for the center radius form, maybe use a different variable because there's a and b in the question. So maybe like x minus p squared plus y, whatever.
Thank you. That's a good point. Yeah, that's a good point. Yes, that's a good point. Yes. Yeah, my apologies for that. Yeah, my apologies for that. Yeah. All right, so if there are no questions, we can take much more advanced. But the point is that to specify the equation of a cycle, you need the center and you need the radius. So sometimes the general problem will be such that you are given 2 points, the center and the one of the point on the cycle, and then from there you can use the general equation to
Sorry,
find.
sir. There's a request to do 2.2 again. If you could just
2.2.
Yeah, the one you just,
2.2 again. Yeah.
Please.
Okay. Yes. So what
There's someone said you must move the paper up so that they can see. Yeah, that true. Okay.
Yes. So the question is find the radius of the cycle. So this is a general formula. You have P squared plus Y minus Q squared is equals to R squared. So we are avoiding to use A and B because in this case we are given the coefficient of X squared and Y squared as A, so that would be confusing. So how do we proceed? So the first thing that we do, we divide by A. So we divide by A on both sides. Let's call this of equation 1. So when we do that, we have X squared plus Y squared is equals to B over A, right? This already looks familiar. So this tells us that we have a cycle that is centered at the origin. And normally we will have X squared or R squared. This is the equation we have. So that means that we have R squared is equals to B over A. So to find the radius, we take the square roots of both sides. This will give us that plus or minus. Now in this case, we know that the radius is a physical quantity, which is a distance, and the distance is always positive. So, which means our radius will be that. All right, so I'm not sure if I should ask for a feedback if this was clear.
That was very clear. Thank you.
Okay, thank you. So now we have another question, question number 3. This is the question. So again, 3 minutes. Yes, determine the equation of a cycle with the center, it's the origin and the radius of 2 square root of 7.
Sorry, sir, can we make the question just slightly bigger, just a bit of a zoom? Okay, that's fine, that's fine.
Okay, thank you. All right, so let's find the solution. So in this case, we always start from a general formula. X squared minus A x minus a all squared minus b squared is equals to r squared. This is step number 1. You start from here. So now you are told that the center, it's the origin. So that means that a is equals to 0, b is equals to 0. So we go back to the equation, we substitute. That's number 2, x 0, x minus 0 all squared, y minus 0 all squared is equals to r squared. So that would give us x squared plus y squared is equals to r. That's the second step. Number 3, we are also given the radius, that the radius in this case is 2 square root of 7. So we can see that to find r squared, we have to take r all squared. So this is equals to so this is 4. So this is 7. So this gives us 28. So we have r squared. R squared is 28. Then we put it all together. We have, this is our equation of a cycle.
Thank you, sir. We've got a request to do an example where there's completing the square.
That's beautiful.
To find the center and radius. Thank you.
Thank you. That's a very a good request. So we can find something very interesting. Let's allow our students
Wait,
to.
sorry, sir. Can you please show that paper again?
So that.
What happened?
So which.
Wait, lift it up a bit.
You mean this question number 3?
No, the answers.
Or the answer, yes.
Thank you, sir.
Okay, perfect. All right, so here is a present for you. Question number 7. Determine the center. That's number 1. And then number 2, you find the radius. So 4 minutes. So you attempt it and then we can all work on it. Can people see the question?
No, we can't see.
Just bring it a bit lower, please.
Yeah,
a bit lower and zoom. Thank you.
Okay. My apologies.
No problem. Can we zoom it? It's just a bit bigger, please.
Let me try. How is that?
That's beautiful. That's beautiful. Perfect. Just there. Thank you, sir.
Perfect. Thank you.
In the meantime, colleague, I would like to remind the student to make sure that they do fill the register there. Everyone attending this session, they must make sure that they don't leave this session without having followed the link, necessary link for the register. I've already uploaded the link on the chat box. Please make sure that you don't leave this session without having followed that link. Later toward the end, I'll post another link to check how are you receiving our session, guys. So make sure that you make use of the two links before you exit, please. Thank you.
Can complete a square. So the rules of completing a square is that you take the coefficient of this term, you divide it by 2, you square it, you add and subtract. So what we do, divided by 2 square. What you do on the right hand side, you also do on the left hand side. So this will give us plus all squared. So now we take care of the second part. We do the same thing. So you follow the logic. So we also add, right, clean. So if we simplify that, give us 8 divided by 4, divided by 2, that is 4.
Sorry, sir, just move your page a bit up, please. We need to see. Okay. Yes, thank you.
Yes, so that gives us 16. So 8 divided by 2 is 4, 4 squared is 16. Then we have that, this is 1. Then we can have 20 plus 16 plus 1. So now this is 4 squared plus 1 squared is equals to 17, 10, 37. All right. So are people comfortable moving from that point to here?
Maybe just explain that part one more time before you go to the, so line 2. When you added the minus 8 over 2 squared to both sides from there.
Oh, sir, can I explain here? This is like the difference of 2 squares, ne?
Mm-hmm.
Yeah, so there's other way that our teacher let us read, like here, 2 negative 8 over 2 all squared. You can bring 8x squared minus 8x plus into negative 4 squared plus y squared minus 2y into negative 1 squared equal to 37. And then when you are at this point, you take what is similar, like the x squared, like minus 4x has squared on it. So yeah, you can say take those with squared and
sorry, can you give sir a chance to finish, then you can ask your questions. Sorry to sorry.
Okay, good. Yeah, so so this could be a separate session in itself. So what we realize is that if you complete a square, the rule is that first, number 1, you take the coefficient, you divide it by 2, you square it. So when you do that, this will give you what? 16. Now you have the right hand side. So what you do, you add and you subtract. So you do the same thing for the y component or the y term. You take the coefficient, which is in this case, this is 2, -2 divided by 2, you square it. What do you get? You get 1. So plus that, plus 1 minus 1. So this is equals to 20. So you then transpose the negative terms. Yeah, so these terms. So what you will remain with is x squared plus 16 plus xy squared minus 2a plus 1 is equals to 20 plus 16 plus 1. And that will give you 37. Now, at this point, you just need to know how to factorize.
Sorry,
So
there's a request that you need to move the paper. You can't see anymore. Yes. Yeah, thank you.
yes, you just need to know how to factorize. And I'm not sure if I need to explain that part. Or it needs
Maybe just to say what the center is and what the radius is from there.
Okay, perfect. So now at this point, we can see that we have a general formula. Yes. So we can already identify that in this case, our center, what is x, is 4. So if you say this is equals to 0, x is 4, then y is 1. So our center is 4, 1. Then our radius, yes, and our radius, we can see that in this case, this is r squared. Therefore, r is a square root of this. So as we have emphasized before, you only take positive r. So when you leave it here, this is good enough. Someone with a calculator can finish that if they really want to have a specific number. So yeah, let's recap. So now you will be given an equation of a cycle of that form. They ask you to find the center of that cycle and also the radius. What you do, you want to have it in that form. So you then complete a square, which is a different exercise that you can perform. And then eventually you will have your equation of a cycle in that fashion. Now you need to identify the center. You then have your general equation, and we can see that the center in this case has coordinates 4 and 1, and the radius is square root of 37. So that's how you solve it. So if you feel like you do have a challenge of completing a square, so this is from previous videos. If you go to the website, you can find that there are videos which these ideas are being explained. Yes, or if my colleagues, they can intervene on how we can assist in that direction. I don't know, maybe just comments, because I feel like maybe the hassle is just here.
I think it's fine for now. We'll address questions at the end. If we can take another example or move to the next question.
Okay, I think let's
Sorry,
move.
sir.
Yes.
So like, do you have an example where you have maybe a circle and then you have a quadrilateral and a tangent attached to a circle or something.
Yeah, we don't have that example, unfortunately. Maybe my
Okay, so
colleagues, they can assist me, but we have such a problem. Can you see this?
okay, so
Yeah, so yeah, can you attempt this? Let's have 4 minutes. Maybe 4 minutes is just to give a rough idea of the solution, then we can solve it.
Yeah, that's perfect. Thank you.
Thank you.
Sir, please, can you zoom the question? I don't see it.
Question number 8. Can you see now?
Yes, thank you, thank you.
Okay. All right, so let's try to see the solution. Okay, so again, we start from that point, we write the equation as 2y is equals to 0. Okay, perfect. Okay, perfect. So the first step, we need to be able to write our equation of a cycling in that way. The question that we are being asked here is to find the equation of a tangent to the cycling of that nature. So before we go there, we need to find the center, AB, and we need to find the radius. So how do we find the center? First, we take the equation, we complete a square so that we can write it. So x squared minus 6. So we take 6 divided by negative 6 divided by 2 all squared. This is equals to what? 9, right? 9 plus, we add, we subtract, we go to the next term. Again, we take the coefficient, we divide it by 2, we square, we get 1. We add, we subtract, get 0. Yes, so from here, we transpose these two terms. So we remain with, which is 9 plus 1, that is equals to 10. So from here, we can just use that. So we can see that the center in this case, it's 3 and -1. How do we find that? We say x is equals to 0, x minus 1 is equals to 0. Then we solve for x is 3. Now, we also do the same thing for y. We solve for y, we get -1. So that gives us our coordinates. Beautiful. And we can see that the radius, so which means r is 10, since that is the case. So one problem down, but we are not done. We haven't solved the complete problem. We want to find the equation of a tangent that touches the cycle.
There's a request that you can explain that again.
So which part? The whole part?
I think she didn't specify which parts. Let me check.
Yeah, I think, yeah, the completing the square.
So when you are completing a square, so you have, maybe let's do it separately, because I maybe this is the main issue. You have x squared minus x is equals to 0. Let's say we have that. That is our problem. So we want to complete a square. What do we do? The first step, you take the coefficient. So in general, you will have x squared a plus b x. Let's put it that way. So in this case, we can have x squared b over a, x is equals to 0. So the coefficient of x. So you take the coefficient of x, you divide it by 2, you square that. So when you do that, you get -3 squared is equals to 9, right? So you then say, okay, I have 9, I add, I also subtract. So you then transpose -9 to the right-hand side. You have that as. So this is something that we are familiar with. So, and the solution in this case is this. So let's see if this is a good solution. So if we expand x3, what do we get? X squared, and then plus 9. So this gives us what we have. So this is correct. Right. So coming back to our our problem. So you do the same thing for the y, you complete a square, and then you will eventually get that. So this gives us our center. And how do we find our center? We say x minus 1, minus 3 is equals to 0. You solve for x, you find that x is equals to positive 3. You also said y plus 1 is equals to 0. That give you y is equals to negative 1. So this is the center. Now someone has done work and they have drawn the cycle. So we have a cycle which is centered at negative, at 3, a negative 1 coordinate, and we have been given another point, which is, we can call it P, which is X. So the question is, find the equation of this line, which is a tangent. So we want to be able to say that it's equal to C. So we want to find, so which means we need to find the gradient, we need to find the y-intercept. Right? So how do we move from there? Okay. So what we can notice from our previous knowledge is that if you look at the relationship between the radius and that cycle, they are perpendicular to each other. And we have a special rule. So if we call this M1, the gradient of a line, say this is O to P, and we call that M2. So what we are told is that when you take the product of M1 times M2, that should give you a negative 1. This is the truth we know from analytical geometry. So now all we need to do is to find the gradient M1, and then from there we can get.
Sorry, sir. Maybe just say why is the radius perpendicular to that tangent?
Yeah, that's a very deep question. Yeah, maybe could you assist me to give that argument?
No, because you mentioned it slightly before. The radius is perpendicular to the tangent. That's from our grade 11 theorems that we use.
Yes.
Our grade 11 theorems, the radius is perpendicular to the tangent. Thank you.
Yes, thank you. Yes. So yeah, so this is a theorem that is well known from the Euclidean geometry. That's the radius of a cycle is always perpendicular to the line that is tangent to the cycle, and it's tangent because it only touches one point of the cycle. So yes, so from there, once we know that when we have two lines that are perpendicular, the relationship between their gradients is such that when you multiply their gradient, they will always give you negative 1. So we will use this rule to allow us to say if we calculate the gradient of M1, it can give us M2. So that allows us to solve one problem. And then the second step is to use point P to find the y-intercept. Then we're done. We'll be having the equation of the tangent to that cycle. So let's start. So this is a formula to calculate the gradient. We have now in this case, So we have O 2 point. Point O has 3. This is the center of the cycle. And then we have P, which is a point on the cycle, which is 4. And then X is left. So let's call that X1. Let's call that Y1. Let's call this X2. Let's call that Y2. Okay, so from here, it becomes a very straightforward problem. When you substitute, Y2 is what is 2 minus Y1, 1, divided by X2 is 4, X1 is 3. So this gives us, so we have what? 3. So that is the gradient of M1. Now we can use this, we can say, okay, M1 times M2 is equal to -1. So we substitute M1 times M2. So therefore M2 is equal to -1/3. Right? And this makes sense because the gradient is negative by just looking at the graph. So problem number 1 solved. We have the gradient. Now we need to find the y-intercept. So we can start from here and say we have so we substitute the gradient x plus c y. So in this case, we have a point.
Just move the paper a bit up, please. Thank you.
Okay, so we have a point P, which is 4, 2. Now we can see that we can say x is 4, y is 2. So we substitute, we have right. So therefore 2 minus plus 4/3 is 6 plus 4. So this is 10/3. So therefore the y-intercept done everything correctly. So we have that's 10/3. That is the equation of a tangent. So we have solved the problem. Yes, so I will allow for my colleagues to emphasize important points and maybe point out where I could have missed, or if there are any questions from the students themselves.
Sir.
Yes.
Sir, I'm confused as to why we had to first complete the square to find the coordinates, -3 and 1, yeah, at the center, say, instead of just calculating the gradient. Why we had to first complete the square? I'm confused, sir, because we already had the coordinates.
Yeah, that's a good point. Now, in this case, normally, you would be given the equation of a cycle. This where it would end. So you would have to start just from here. They would just say, find the equation of a tangent to a cycle, x squared minus x squared, minus 6x plus x squared plus 2y. Yeah. So this is an extra information that has been provided after someone has done some calculations. But yours will start here. Now, for you to solve this problem, you should also be given a point in which this line is passing, which is 4 to P. So then this question will be complete. Find the equation of a tangent to a cycle, and if you are given that the line touches the cycle at the point P, which is 4 with coordinate 4, 2. So this will be a complete question. So now, if you are given a question of this nature, then you need 2 points to calculate the gradient. So now that second point comes from the center of a cycle. So that's why you have to complete a square to find that point, so that you can use point O and P to calculate the gradient. And once you have the gradient, you can then use this fact to calculate the gradient of a tangent.
Oh, say what? Oh, say I thought it was already given. Like,
yeah, my apologies. That is a confusion situation.
Just also just to give more practice on the completing the square.
Yes. So
yeah.
Yeah, I do have one last question, and I think can people see my screen?
Yes, we can see
yes,
it.
You can see, yes.
You can zoom it just slightly.
Yes.
Okay.
Perfect.
Yeah. So this is what you should expect from a test. You will be given an equation of a cycle, and you are told that there is a point that is on the cycle. So now someone can ask you, like, for instance, 9.4 to find the equation of a tangent to a cycle given that point. So for you to do that, you have to calculate the gradient. And for you to calculate the gradient, you need 2 points. So first, you must complete a square. Yeah. So can we just, for the last time, we attempt this problem, and number 1, and then, yeah.
Good evening, sir.
Yes.
I wanted to ask from the previous question that why didn't we use the center to find the equation of the circle? Because I tried both of them, and with point P, the answer did come out, but with point O being the center, it didn't exactly give me the answer.
Okay, so let me try and bring it
Must
back.
I take that question? Or are you fine?
Yes, please do. Please do say. Please do.
Yeah, sorry. Remember, when you the point, the center, right, does not lie on the circumference of the circle by definition. So if you're using the center, you'll use that as your A and B. So in x minus a all squared plus y minus b all squared equals r squared, your center, the coordinates of the center is reserved for A and B. Then to find the r, you have to use a point that lies on the circumference of the circle, and then you'll get it. Are you answered?
Yes, answered. Thank you.
Perfect. Thank you, sir. Thank you. All right. So let's work on this problem. All right. So in the interest of time, I hope you have you had some opportunity to make an attempt. So let's discuss the solution. All right. So we are given the equation of a cycle and a point, let's call it P. So the first question, they ask you to determine the center of a cycle. So now, for us to do that, we need to have the equation that is provided in this form. It must be in that form. So we take x squared, y squared, minus 4x plus 2y plus k is equals to 0. So we put similar terms together. We transpose k. So we complete a square. So meaning we take the coefficient divided by 2, you square. That gives you what? 4. So you add 4, you subtract 4. You do the same thing. Take 2 divided by 2 squared is equals to 1 plus 1 minus k. So you transpose these negative terms, you remain with squared plus 4 plus y squared plus 2y plus y is equals to 5 minus k. So from here, you get so we can see now that our center is 2, -1. Yeah. and r squared is -5. Okay. So that is 9.1. So to deal with yeah, are there any questions from this solution? Or we will discuss as soon as we finish all the questions.
And let's take questions at the end.
Okay,
We can discuss.
perfect. Yeah. Good. So the next question, they ask us to find the value of k. Now we go back to our solution. X is equals to -2 x squared plus.
Can you just remind us of the original question? Maybe just show us that diagram. Thank you.
Sorry. This is something else. Yes. Yeah. So the first question is to find the center of cycle. The second question is to determine the value of k. Now we have a point at a circumference, as it has been emphasized that to find the radius, you need to use a point at the circumference. So we are going to use point, the coordinate 1, 3. So let's see what's the solution. So we have a point 1, 3. So that means that x is 1, y is 3. We substitute. That would give us 1 minus 2 squared plus 3 plus 1. So we solve for k. We find that k is 17. Yeah. So it's 5. Just 17 minus 5 minus k. This is minus 12. Minus 12. So that's the value of k. Okay. So the next question. Determine the radius of a cycle in a set form. Okay, good. We know that if we go back, we have x squared plus y squared. And we have found the value of k. And right. And we know from a general formula that should be therefore r squared is.
Sorry, sir, just move the paper up a bit, please. Sorry.
Yes. Plus or minus, but r is always positive. Therefore, the radius is the square root of 17. All right. So the last question, determine the equation of a tangent to the cycle at coordinate 1, 3. Okay, let's have a picture of that. So this is this is 17. Then when we draw this
Sorry,
side,
sir, you autofocus on the paper. Yeah, now it's better.
yes. So then we have 0.13. So somewhere there. And then we have yeah, it's not maybe correct, but yeah, forgive me, it should be slightly up there. Yes, just forgive me, it should be somewhere here. Yeah, so what we need to understand is that we have that relationship. So we have 2 points, we call it O, then we call it P. We have M1 for the gradient of the point of the line OP, and we have M2. So the point is to find the equation X. This is M2 plus C. So how do we find the gradient M2? We start by finding the gradient M1. We use this knowledge. So in this case, we can define point O, and we will have this as X1, that is X2, Y2, Y1, sorry. So that's 1, 3. We define that as X2, and we define this as Y2. All right. So when we substitute, we have 3 minus -1, and then we have X2, which is 1, and minus 2. So this is that's the gradient. Now we have this relationship between 2 perpendicular lines. The product of their gradient is equals to -1. So we can substitute M1. We have that already. So therefore M2 is so which means it should be somewhere there. So we have the gradient. Yes, and then now we need to find the y-intercept. So we go to our equation. We have the gradient, it's 1/4 x plus 1. Now we have a point P1 which this line passed through. So when we evaluate at that point, we have 3 is equals to 1 over 4. This is 1. Then we solve for C. This will be 3 minus 1 over 4, which will be 12 minus 1 over 4. That would be 11 over 4. Right? So when we substitute, eventually we have this. So that addressed the last question. On question number 9. All right, so I can just leave it here and allow for questions, comments, and emphasis. So my colleagues, you can respond from here if there is any points. Just to emphasize for this section, because I may have not.
I think you can summarize on just summary question 10, because I think they need that too. It's very important. Just a summary of question 10.
All right. So now for this question, what one needs to understand. Oops. Okay. So we have 2 cycles. So you have center A, B, and you have the center P, Q. And the radius is R, and then maybe this one has a radius small r. Now, to see if these 2 touch each other, so r plus that must be equals to the distance between point, let's call this one O and this one O prime. So O prime. So we're using distance formula. We can find that O prime becomes, if we call this this is just x1, y1, we make x1 to be equals to a, y1, we make it to be equals to b, and we make x2 to be equals to p, and then y2 to be equals to q. So what we have is that p minus a squared plus p and q minus e squared. Yes. So to see if 2 cycles touch each other, they must satisfy this condition. So if you take the distance, if you calculate the distance using the centers of 2 cycles, and it's not equals to the sum of their radius, then they do not touch each other. But if this condition is satisfied, then that's the case. So if we look at this situation, we have x squared plus y squared is equals to 16. And we have a cycle x squared plus is equal to 1. So you have to prove that these two cycles touch each other. So how do you demonstrate that? Okay, we have already argued that you must show that r squared plus that. We have r for the first cycle, 16 plus 1. Nope. This is not correct. First, maybe let's express this as x minus 0 squared plus 0 squared is equals to 16. So let's call this a bigger r. So we know this is 16 is equals to r squared. Therefore, r squared would be 4 if we take the square root. Yes. And then in this case, we have already in the correct form. So r squared is equals to 1. Then this is 1. So the first thing we do, we take the sum of the radius. This is equals to 4 plus 1 is equals to 5. Clean. Now this side must be equals to the distance between the two centers. So as we have demonstrated before, this would be p minus a squared plus q minus b squared. Now in this case, allow me to say that a b is equals to 0, 0, because a here is 0 and then b. Then we use that to be p and q. Therefore, pq will be 4 minus 3. So when we substitute, we get, so we have p is 4 minus 0 squared plus what is this? We have q is negative 1 minus 0 all squared. Yes, so now working this out gave us 16 plus 9, that is 25, which is square root of minus 5. So we take positive because it's a distance. Now this proves that these indeed touch each other because they satisfy that condition. All right. Yeah, I'm not sure if that was too fast or it was a reasonable pace.
So just a technicality there.
Okay, you can give more clarity.
No, just on your solution. I think if you go back to that screen, I just want to.
What I'm showing here now.
In your solution, yeah, your solution. I just want to, yeah. You see in your notation, you got r plus r is equal to 5. That one's perfect because you're working out the sum of the radii. Then in your next one that you got boxed, remember you said that the center was O and O prime.
Yes.
So instead of r plus r, it should be O prime. is equal to that square root.
Oh, yeah. No, that's right. That's right.
That's right. That's one. Yeah. And then just further down, the square root of 25 is just 5. There's no plus and minus there because the distance formula is the positive square root. So
Yes.
it goes straight to positive 5. Yeah. That was good.
Yes. All right. No, thank you. Thank you. That's a very appreciated contribution. All right. So that's all for the day. I hope this very quick introduction was helpful. I will allow my colleagues to make comments, even to refer students to other links from previous years. And maybe if there's something to be mentioned, I'll just end here and hand over to my colleagues, Siabonga, or my other colleagues who may wish to emphasize important points when you are dealing with this section on the analytical geometry of a cycling and the tangent and the equation of a tangent to a cycling. Yeah, that's all on my side.
Thank you so much, my brother. Thank you so much for a wonderful session. As I requested earlier, guys, everyone who's attending this session, I can say now we have lost about half students who started with us in this session. So can you please make sure that you don't just leave the session, guys. We are just requesting you to make sure that you have signed the attendance register by following the relevant link there on the chat box, as well as your feedback, guys, is very much important to us. So please also follow that link for the feedback as well. Make sure you don't just leave without having done that. For other recordings, guys, as I said, that our recordings, guys, are recorded and uploaded on our website. So they are compiled and uploaded on our website. So you can check anytime. Maybe you'll find some old recordings as well. And then as well as the new recordings will be uploaded in due time as well. Unless you have some questions, you're free to ask those questions as well before we want to have your we want to have your record, guys. That's why you have to make sure that you have signed the register. We want to have a record with who was with us, because we have to check on these things even as we continue our program, guys. We have to check who is consistent with us, who's not consistent with us.
Sir, I've been trying to look for the register, say, from the chats. I can't find it.
The link, there's a link there. Just click on the link.
Yes, the link. Oh, okay. Thank you, sir. Here is it.
Yes, as well as the feedback link as well. Is there. So also, as soon as you're done with the register, also give us feedback, guys. We would like to know how are you receiving our sessions, guys? So that we can see after improve accordingly. So make sure, guys, if you have a question, feel free to ask. Thank you. Yeah. Otherwise, if you are sorted, it's fine. You can feel free to exit. But if you still have some things to ask, it's fine. You can ask. We are here for you.
Yes, Lutul, you can talk.
Yes, sir. Can
I
you
can see
please
that.
send again the link for WhatsApp?
Oh, okay.
Okay.
You shared just now.
Yes. Done. It is pasted now. You can follow the WhatsApp link as well. Thank you. Lutul, I see your hand is up. You can talk. Senator Lutul.
I think it was a hand for before, not just now. Yeah, yeah.
But the look of things is same like everyone is sorted, guys. I would like to thank you so much again, guys, even for your passion throughout the session, guys. Wonkaba too from the facilitating session as well as on the chat box. Thank you so much, guys. Thank you so much. See you next time.
No, thank you so much.